Welcome to the Selwyn District Matariki Skyguide. My name is Karen Pollard and I'm an Associate Professor at the University of Canterbury and the Director of the University of Canterbury Mount John Observatory. A special note about Matariki. Matariki is both an event and a celestial object. The Maori legend of Matariki is told elsewhere, but for viewing purposes, it's the same grouping of stars as the northern Pleiades, also known as M45 in the Messier Astronomical Catalogue. The timing of the event Matariki is linked to what is known as the heliacal rising of the Matariki or Pleiades group of stars, or for southern iwi, the star Rigel or Puaka. Unfortunately, only early risers will get to see this event. The term heliacal rising denotes the first time an object's visible just before dawn, after a period when it hasn't been seen or visible at night. Matariki is not visible during late March to mid-June as it's too close to the sun. Thus, if you wish to observe Matariki, you'll need to be up in the wee small hours of late June to early July to see it rising in the dawn sky. The date given for the start of Matariki this year is the 13th of July 2020. We'll begin by looking towards the south. If your phone doesn't have a compass, then simply look up and locate the Milky Way. In mid-June, at this time of the evening, it arches high across the southern sky. So stretch out your arms, your left hand will point east and your right arm will point west. If you have to crane your head back to see the Milky Way, then you're facing the wrong way for now anyway. Once you're looking south, try to find the brightest star in that part of the sky. It should be about a third of the way up from the horizon to the zenith, which is the point directly above your head, and over towards the southwest. Facing south, this will be slightly to your right. This star is Canopus, or Atutahi in Te Reo Māori, and it's the second brightest star in the night sky. The brightest star, Sirius, or Takarua, will be setting further to the west. It's unlikely to be visible unless you happen to have climbed a very tall mountain and have a clear view to the horizon. Sirius, Takarua, is actually a multiple star system. It consists of two stars that orbit each other. We see the brightest one of these, but its companion is much dimmer, and so our eyes can't see it. Now, look more widely at the sky. Of all the stars you can see, about half of them are multiple star systems. Double stars, like Sirius, are known as binary systems and make up most of the multiple star systems. However, there are others that contain many more stars, all the way up to 6 stars, with each star bound to the others by gravity and revolving about a common central point. Come back to Canopus. We'll start our first big star hop. Hold your right hand at arm's length with your palm facing the sky. Now make bunny ears with your index finger and little finger. Place the tip of your little finger just below Canopus. If you now look just a wee bit above and to the right of your index finger, you should see what appears to be a dimly luminous cloud. It will be about a finger's width. This is the Large Magellanic Cloud, or LMC. It's one of 2 dwarf galaxies visible in the southern half of the sky. The other dwarf galaxy is the Small Magellanic Cloud, or SMC. It can be found about another handspan down and to the left of the LMC. While not tiny in their own right, both of the LMC and the SMC are much smaller than our own Milky Way. Our huge galaxy has the same mass as about 100 LMCs and almost 165 SMCs. Because of this size difference, it's believed that the Milky Way captured them with its much larger gravity as they passed by ages ago. They are now considered satellite galaxies. In other words, they orbit our galaxy in much the same way as satellites go around the Earth. So, let's get back to the sky. We'll do a big hop this time. Imagine a line that connects the LMC and the SMC. Now, imagine a line going up at right angles to that line at the centre of it. If you go 3 handspans up along that line, you'll find a pair of bright stars. These are Alpha and Beta Centauri. Alpha Centauri, also known as Rigel Kentaurus, is the brighter one. In fact, it's the 3rd brightest star in the night sky. It's actually a triple star system. It also holds the distinction of being the closest star to Earth other than our own Sun. Close is a relative term, of course. Alpha Centauri is 4.3 light years away. To give you an idea of that distance, it takes light 8 minutes to get to Earth from the Sun, and Alpha Cen is just over 270,000 times that distance. Although this sounds like a long way, astronomers regard it as not just in our backyard, but practically knocking on our back door. Together, Alpha and Beta Centauri are known as the pointers. Point to what, you say? Draw another imaginary line from Alpha to Beta Centauri, then continue that line twice the distance further to a group of 4 stars that form a kite shape. This is our most famous constellation, the Southern Cross, whose official constellation name is Crux. It's the smallest constellation in the night sky, but it's a proper gem floating in a river of light. Speaking of which, if you happen to have binoculars with you, find the bright star on the left end of Crux's short axis. Centre it in the binocular's field of view. Just to the left and slightly down from that star is a small grouping of stars. This is the Jewel Box cluster. It's well known amongst observers for its collection of brilliantly coloured stars. Zooming back out to naked eye, follow along the Milky Way to a bright patch a little less than 1 set of bunny ears away to the west. This is the Eta Carina Nebula. In astrospeak, a nebula is a cloud of gas and dust. The Milky Way has many such clouds, but this one's impressive for a lot of reasons. First, it's visually the largest one we can see with our eyes. Second, it's a stellar nursery where baby stars are busy being formed. Third, it has a truly massive binary star system, slightly orange in colour, that's due to self-destruct in a huge hypernova explosion. This explosion will be so powerful that we theoretically should be able to see it as a star in our daytime sky for some time, even though what's going to be left of the star will be over 7,500 light years away. So just to the left and below the nebula, you'll see a fuzzy patch of stars. These are the southern Pleiades, the counterpart of the more famous Pleiades, or Matariki, in the northern hemisphere. Like the Jewel cluster, these stars are likely born from the same stellar nursery and are therefore a family of stars travelling together through space. This cluster has around 70 hot young stars, but only a handful can be seen with the naked eye. Most of us will only be able to visually resolve 1 or 2, but the keener-eyed youngsters may be able to see some more if the sky conditions are good. Has anyone in your group seen a shooting star yet tonight? Keep your eyes peeled. Although there are no major meteor showers at this time of year, observers can see meteors blazing across the sky on any night of the year. So let's turn around and face north for a change of scenery. The first thing most residents of Selwyn will notice is, unfortunately, a rather large light bubble rising up over the city of Christchurch. By now your eyes will have dark adapted sufficiently to make this quite noticeable, and if you scan around the horizon in all directions, you may see a few smaller ones from other communities in the area. Keeping our skies dark is one of the main aims of an international group of dedicated amateur and professional astronomers. We want to maintain the joy of seeing innumerable stars in a clear, dark sky and pass that joy along to the children of the next generation. If you want to know more about this, go to www.darksky.org. Luckily, because we live in New Zealand, even light polluted skies are nowhere near as bad as they are elsewhere in the world, and many interesting sights are still available. We'll search for our second constellation tonight. Facing north and looking to the east, now on your right, look up about halfway to the zenith, just along the northern edge of the Milky Way. You are looking for a moderately bright, pale orange star. This is Alpha Scorpio, better known as Antares or Rehua in Te Reo Māori. Because it resides in the middle of the Scorpius constellation, it is commonly regarded as the heart of the Scorpion. Antares is a class of star known as a red supergiant, which includes some of the largest stars in our galaxy. In that respect, Antares is no exception. It could hold approximately 300 million of our suns inside it. Despite its size, its surface is quite cool as far as stars go, and that is why it has a reddish tinge to it. In general, blue stars are hot, like the ones in the southern Pleiades, and the red stars are cool. Depending on sky conditions, the rest of Scorpius may be a bit challenging to find as it consists of slightly dimmer stars. It's best to use an app or the chart below to help trace it out. Starting from Antares, follow a 4-star arc to the right that rises slightly towards the Milky Way. The 4th star is about one set of bunny ears away from Antares. At this point, the constellation takes a curve downwards into a hook shape that ends in a pair of stars, Scorpius's stinger. In the other direction, you should see 3 or 4 stars that fan out about 3 finger widths away to the left of Antares. These represent Scorpius's claws. The Greeks weren't the only ones to recognise the characteristic shape of Scorpius. This constellation is an important one in Polynesian lore, in that it represents Maui's fishing hook. In New Zealand, lore has it that Maui hooked up the North Island from the ocean floor. For those of you wanting to learn more about this story and others from Tātai Ararangi, there are many good sources these days on the internet. Start your journey at www.maoriastronomy.co.nz or the Encyclopedia of New Zealand Aotearoa, www.teara.govt.nz. If you have a clear view to the east, you may have noticed a very bright star rising up over the last half hour. This is not actually a star, it's a planet, and no less than our largest one, Jupiter. There will be no missing it as one of the brightest objects in our night sky. Not bad for something that's about 640 million kilometres from us and isn't a star. For those of you carrying binoculars, see if you can spot the 4 Galilean moons that orbit this giant planet. You may only be able to see 2 or 3 because 1 or more are occasionally hidden as they circle around behind it. This planet actually has 79 moons, but the Galilean ones are the only ones visible to us without quite powerful telescopes. Closer to 9 p.m, you should be able to see Saturn starting to rise in the east. This will be much dimmer than Jupiter, but still quite noticeable, and a distinctly yellowish hue compared to its bigger brother. This close to the horizon, it will likely appear a little bit fuzzier as well, because you're viewing it through more of our atmosphere. Optically, the atmosphere bubbles a bit like a pot of boiling water. This turbulence can affect our viewing as we get closer to the horizon. To check this out, look at some stars near the horizon and then compare them to those close to the zenith, directly above your head. You should see the ones further down twinkling, but as you move up, that twinkling effect should mostly disappear. Finally, let's widen our view to take in the Milky Way. When you look at this cloudy path that spans our night sky, you're actually looking at some millions upon millions of stars that make up our galaxy. The Milky Way galaxy is a flattish disk with several spiral arms, and when we look towards it from our home here on the Earth, we are looking at the disk that surrounds us. The centre of that disk is in fact just rising in the east. If you look that way, and it's dark enough where you are, you may see that the Milky Way begins to bulge out to the north and the south. Behind that bulge, hidden by much dust and many stars, is the massive black hole that's kept all those stars spinning together through space, and will do so for many more billions of years to come.